So, good evening, everyone, and this is Ray Optics lecture number 7. And I guess this is the class where we are going to deal with ray diagrams and all the other things. These things, let me just adjust this. These things may be known to you beforehand, but what you got to do is understand them and remember them. Now, remember, since the class has been bifurcated and we are dealing with the NEET students, remember any question that comes in ray optics is going to be a very simple one, a very simple one, a very simple one. We just need to remember these small things, and if we can remember small things, the question will be a question that can be solved in a split second. Just to make you recollect what we had done in the previous class. In the previous class, I think I had shown you these three rules: rule number 1, rule number 2, and rule number 3. Yes or no? Do we remember this rule number 1, rule number 2, and rule number 3? Yes. Today, in today's class, we will go ahead and just write these rules. Again, it is not important for you to even write it. If you know these rules, you may not have to draw the ray diagram even. I am sure that you know these rules. I will just go through them fatafat so that we are not going to see any question where you will have to draw the ray diagram. I am sure ray diagram is already done in your 10th standard, so you might not be getting any question which is based on a ray diagram, but you must be knowing how to draw it, and that is the reason that I am showing you this. The first rule everyone knows: if the incident ray is parallel to the principal axis, the reflected ray, if I just draw, this is the green ray, which is the incident ray. It is parallel to the principal axis. The blue ray is the reflected ray. A ray which is parallel to the principal axis after reflection will pass through the focus. We all remember this? We all understand this? Yes or
Sir,
no? It is as simple as this. This is the case of a concave mirror. What happens in the case of a convex mirror, beta? What happens in the case of a convex mirror? What happens to the ray which is parallel to the principal axis? What happens in case of a convex mirror? Do we know this? Yes or
appears to
no?
be passing through focus.
It appears to be not passing through the focus, bacha. It appears to be converging from the focus, and I will just show you that diagram as well, and that is just copy pasted from the previous class. These are the two diagrams which make us understand a rule number 1. For concave mirrors, it will definitely pass through the focus. That is rule number 1. This ray is your incident ray parallel to principal axis. This ray is your reflected ray. It will always pass through focus. Remember, we are talking about parallaxial rays, and we are talking about mirrors which have small apertures. In case of a convex mirror, it cannot pass through focus. This is the ray of light which is incident, which is parallel to the principal axis, and it will appear to come from the focus. So both the definitions are same, but they look different. Why do they look different? Because of the mirrors are different. Do we understand this? Yes or no? Have you drawn this? This is your diagram number 1. Rule number 1: a ray of light which is parallel to the principal axis will pass through the focus. Now, the second point can be written. Let us move on to the second point. Everyone is done with this? We all know this, yes or no? Yes. Then let us write the second point, and the second point is just the reverse of this. I hope you understand when I say reverse, what do I mean by reverse? And I will just show you the diagram. I'll just show you the diagram for rule number 2. What is the diagram for rule number 2? What would be rule number 2? In rule number 2, what will happen is the reverse of this, a ray of light which is passing through the focus, as you can see, which is passing through the focus after reflection will become parallel to the principal axis. So this ray is the reverse of the ray that we had seen. Everyone understands this? Yes or no? I hope everyone is understanding this. Now, what happens in case of a convex mirror is similar, but again, the diagram looks a bit different. Why it looks different? It looks different because it looks different because it looks different because it is a convex mirror. I will go back to rule number 1. Let me first show you rule number 2. Rule number 1, just leave some space. I will go back to rule number 2. Okay, you don't have a mic. Okay, so rule number 2 is the reverse of rule number 1. In rule number 2, what is happening is you have a ray of light which is passing through the focus. After reflection, it becomes parallel to principal axis. In case of convex mirror, it will be going towards the focus. It never reaches the focus, obviously. After reflection, it becomes parallel to the principal axis. I'll give you time to first note down this rule number 2. Then I'll go back and show you rule number 1 as well. Don't worry. Okay. So once you are done, please raise your hands for rule number 2. I'll take you back to rule number 1 also. Rule number 1 is just the reverse of this. Ray of light was parallel. So if you just reverse the arrow, it becomes rule number 1. So in rule number 1, what would happen is this light will go like this in the green direction, and it will be going back in the blue direction. So if you draw that one, that will be rule number 1. If you draw the reverse direction, that will be rule number 2. Do we understand this? You just have to reverse the direction. You just have to reverse the direction. Rule number 1 becomes rule number 2. Rule number 2 becomes rule number 1. Have you noted down rule number 2? Yes or no, my dear friends? Okay. Since you have noted down rule number 2, I'll just give you a snapshot of rule number 1. This is a diagram for rule number 1. As you can see, the direction has been reversed. Incident ray, oops, wrong color. Incident ray is parallel. Incident ray is parallel to principal axis. The reflected ray passes through the focus. In case of a concave mirror, it actually passes through focus. In case of convex mirror, it appears to come from the focus. Rule number 1, you reverse the direction, it becomes rule number 2. I'll give you time to note it down. Once you Note it down. Please let me know. I will move on to rule number 3. Once you note it down, don't worry, I'll give you time. I'm giving you time. We have time right now. So I will give you time. Once you are done, please let me know, sir, we are done. And then I will move ahead with the discussion. Are you done, beta? Rule number 1 and rule number 2. Shall we move ahead in life? Just raise your hands. I'll know. Yes, beta. Shall we move? Raise hands will let me know that we are done with rule number 1 and rule number 2.
Done, sir.
Okay, sir. There was no point before rule number 1, beta. That was simply rule number 1. If you want to see, you can see it now. If the incident ray is parallel to principal axis, the reflected ray passes through the focus. That is where we started. That is where we started, beta. That is where we started from. That was just the statement, nothing else. You want to write the statement, you can write the statement. Remember, no one is going to ask you to draw the ray diagram. Just for your understanding. Just have to understand this one. Anyways, you write rule number 1, incident ray is parallel to principal axis. The reflected ray will pass through the focus. Incident ray is green one. Reflected ray is the blue one. Shall we move ahead now? Yes? What happened? You want to see rule number 2? Okay. Rule number 2 is here. Rule number 2. A ray of light which passes through the focus. A ray of light, the green ray, which passes through the focus. After reflection, will become parallel to the principal axis. It is simple. It is the opposite of rule number 1. In rule number 1, which I have drawn on the right hand side, the green ray in the incident ray parallel to principal axis. After reflection, it passes through the focus. Okay. Written. Now shall we move ahead? Rule number 1 and 2 done. Okay. Rule number 3 and rule number 3 is pretty damn simple.
Sir, am I audible?
Yes, you are audible. Can we move on now, beta? Rule
Yes,
number 3.
sir.
Okay. Rule number 3 is very simple, very straightforward, and it is on your screen right now. Can you tell me what is rule number 3? A ray of light which passes through which point? Which passes through the center of curvature. A ray of light which passes through the center of curvature. This is the green one which is passing. When it strikes the mirror, at what angle will it strike the mirror? It will strike the mirror at an angle of 90 degrees. That means the angle of incidence would be 0. Its angle of reflection will also be 0, and therefore it is going to retrace its path. That means whatever path it is going, it will come back in the same path. This is rule number 3. Rule number 3, a ray of light which passes through the center of curvature will retrace its path. A ray of light which passes through the center of curvature C will retrace its path. As you can see in diagram number A, this is the case for a concave mirror. It is actually passing through the center of curvature. But my dear friends, you must understand that in case of a convex mirror, it cannot pass through the center of curvature. It will appear to go towards the center of curvature, but it will again retrace its path. So the same thing happens. The two diagrams may look different, but they are representing the same phenomena. Do we understand this? Yes or no? Two diagrams. And remember, this concept is a very important concept, and this might help us in solving some so-called difficult problems. Whenever they say that the image of the object is formed at the same place, the ray must retrace its path. The ray must retrace its path. And if the mirror is concave or convex, for the ray to retrace its path, it has to pass from the center of curvature. Do we understand this? Yes or no? That is rule number 3. Now, out of these 3 rules, you may not have to apply all the 3 rules. Any 2 rules you can apply. 2 rays you can get. You can intersect those 2 rays and you will get your image. So you do not need any other rule apart from these 3 rules. Do we get this? Yes or no? Can I have some raise hand that we understand this? Now, there is a 4th rule as well. If you want, you can write it down. But that does not make any difference to your life. That 4th rule is basically telling us that the angle of incidence and the angle of reflection are always equal. So the 4th rule, if you might have to write, will look like this. The angle of incidence I is equal to angle of reflection. You can always draw a ray which hits the point P. Now when it hits the point P, this is your principal axis. This principal axis becomes the normal. This principal axis becomes the normal, and it is very easy to see that the angle of incidence, green one, will always be equal to the angle of reflection, blue one. Green one, the ray is going like this, and the blue one ray is going like this. You may not have to draw this because angle of incidence is always equal to angle of reflection. That is what we have read in the laws of reflection. So this law is valid for any type of ray that strikes the mirror. Here we have taken one particular ray which strikes the pole of the mirror and nothing else. And nothing else, my dear friend. So if you so require, if you want, you can also use this one as one of your rays. Remember, you do not need more than 2 rays. You do not need more than 2 rays for drawing a ray diagram. And again, remember, ray diagrams are things of the past. They are only asked in 10th standard. in 12th standard, they might be asked in the board exam. You might have to draw them in the board exam, but that is it. They are never asked in competitive exams. So that's it. Have you understood? Have you understood this concept of ray diagram, ray tracing? What are the rules for ray tracing? Yes or no? Shall I move on to the next point? Raise hand will give me more confidence that I can move on. That takes us to the most important concept of this chapter, what I understand, and this most important concept is the sign convention. Now remember, whatever formulae, whatever equation we use in ray optics, they have to be used with sign conventions. It's same as what we had done in the first chapter of physics. Motion in one dimension, s is equal to ut plus half at square, v is equal to u plus at. Do you remember this, beta? S is equal to ut plus half at square, v is equal to u plus at. That time I also said that whenever we are using this equation, we have to use them with sign convention. If you remember that sign convention, positive x was taken as plus, negative x was taken as minus, positive y was taken as plus, and negative y was taken as minus. Do we remember this? Yes or no? If you remember that, then this sign convention becomes very simple because it is on the same track. Now what happens is whenever you have a mirror, whether it's a concave mirror or a convex mirror or a lens, whatever, normally the object is always placed on the left hand side. We always make questions where object is placed on the left hand side. I don't know why. There is no reason why the object cannot be placed on the right hand side, but most of the questions, 99.99% of the question, object is placed on the left hand side. And then we have this important point, pole of the mirror. Do we remember this pole of the mirror, P? Remember this pole of the mirror? Yes or no? So the first thing that you must remember is your object, the green one, is always on the left hand side, and you have the pole of the mirror. It may be a concave mirror, it may be a convex mirror, it may be a concave lens, it may be a convex lens. Pole P. Then there are 4 rules that you will have to remember. Number one, we have already seen, object is placed normally at the left of the mirror. This is normally done, so we just write it like this. Object is normally placed on the left hand side. Now instead of calling it an object, we can say that light is coming from the left hand side. This is light. Light is coming from left hand side. So far so good. Do we understand this? Yes or no? Light is coming from the left hand side. Normally this is what we do. If the light comes from the right hand side, then the story becomes ulta, nothing else. Anyways, number 2, from where, since it's a sign convention, you must have some origin. From where are you going to measure the distances? Distances are always measured from, you must be knowing this. Distances are measured from where? Distances are measured from where? What is their origin? Tell me. Object is your origin.
Pole to object.
Distances are measured from the pole. That is what you saw. See. Distances are measured from the pole which is taken as origin. So my origin becomes my pole of the mirror. This is my origin. All distances are measured from the pole of the mirror. Okay. Okay. So this is my origin. Pole is my origin. What is point number 3? Oops, wrong color. What is point number 3? Anyone? Point number 3. Distances in the direction of light. Distances in the direction of light will be taken as positive. Do we know this? Yes or no? Please raise your hands if we know it. Distances measured in the direction of light are positive. That means, that means, that means, that means my pole is my origin. So if I draw my axis, tongue, 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 tongue. This is one axis. This would be my second axis. This would be my y-axis, and this would be my minus y-axis. Are you getting my point, bacha? I've just drawn the axis as we had drawn in the first chapter. Now distance is measured are measured from the pole in the direction of light, and look at the direction of light is coming from left. That means from the pole, if the distance is on this side, it would be positive. Do we understand this? Now this VE is not looking good, so I'll just write it as positive V. If it is in this direction, right of pole, which is incidentally your plus x-axis, it would be positive. If it is in this direction, it would be negative. Do we understand this? Yes or no? Do we understand this? Yes or no? Can I have some reason that we understand this? So
Yes,
this
sir.
is, yes, beta. Yes, bacha. We understand this?
Understood, sir.
Shall we move on to the fourth point?
Yes, sir.
What would be the fourth point, if anyone can help me?
Distances in the opposite direction of light will be negative.
That I've already said, so I will not say that. I only talk about positive things in my life, my dear friends. I never talk about negative. So only done the positive thing. I did not write the negative one. Yes. What is the next point?
Distances measured
Distance is
distances
measured.
measured from distances measured from pole vertically are positive.
Okay, so
Upwards.
distance is above. That might be the word I was looking for. Distances above principal axis is positive. So if the distance is above the principal axis, it will be taken as positive. As I said, I do not talk about negative in my life. So distance is above x, above y-axis, above point P is positive. That means if the distance is like this, it would be positive. If the distance is, oops, like this, it would be negative. Are you getting my point, bacha? Right, positive, left, negative, top, positive, down, negative. It is same as what we did in your motion in one dimension. Do we remember this? Do we understand this? Yes or no? No, yes. Have you drawn this diagram, bacha? I'll again show this in a better diagram. drawn in a better way. My diagram may not be so enticing, so I'll just show it in one. Have you written it and drawn the diagram that I had drawn? Yes or no? No, yes. Then you can again have a look in this diagram. Pole P, pole P, the pink one is the origin. Pole P is the origin. The light is coming in this direction, whether it is a concave mirror or it's a convex mirror. Number A is your concave mirror. Number B is your convex mirror. So the same convention is applied. Whether it's a concave mirror or a convex mirror, the same convention is applied. Okay, beta, your mic is not working. I understand. You can just raise your hand. If you have not done it, if you do not understand, this is thumbs down, thumbs up, thumbs down, thumbs up, thumbs down. Works. Okay, so A is your concave mirror and B is your convex mirror. Doesn't matter. Sign convention is same. Sign convention is same. Sign convention is same. And as you can see, my dear friends, this is positive and this is positive. Right side positive, above side positive, and I will not draw the negative side. Why I want to draw the negative side? Here also, this side is positive and this side is positive. The other two sides are negative. And it is very evident in the four quadrants. This one on this side is positive. This one on this side is positive. Let us, for the sake of looking good, let us draw the negatives as well. Positive, negative, positive, negative. Do we understand this? Raise hands will give me more confidence. So it doesn't matter what type of mirror you are operating. The sign convention remains same. I'll give you a minute to draw. You don't have to draw it again and again. If you have drawn my original diagram, that is good enough. These are just diagram drawn to scale, looking good, and that is why I have shown it to you. There is no other reason for me showing this diagram. Once you are done, please raise your hands so that I can move on to the next point. I'll wait till you are done. I'll wait till you are done. Don't worry. Since I have done sign convention, I'll also introduce the what? The mirror formula and the relation, and this is. Shall I move ahead? Yes, the smaller class which does not have camera, which does not have mic. Can you move ahead, beta? Acha? Okay, then we come very quickly to those relations that we already know, and we will just write them in a flash. Number one relation number one. F is equal to R by 2. Yes or no? No, yes. We know this relation? Yes or no? Now remember, this relation is only valid for parallaxial rays. Parallaxial rays, the rays which are falling at small angles, because if the angle becomes large, then we have a problem. And I'll show you that problem. Don't worry. I'll show you. I'll give you that formula for that one as well. F is equal to R by 2. Everyone understand this? Yes or no? No, yes? Then the second formula is known as the mirror formula. Everyone understands this mirror formula? Everyone understands this mirror formula? Can you tell me what is the mirror formula, my dear friends?
One by F is equals to 1 by U minus 1 by V.
1 by U minus 1 by V? Mirror formula, my dear friends.
1 by F is equals to 1 by U plus 1 by V.
Okay, good. We can make stupid mistakes. Someone in the Indian cricket team made a stupid mistake in the last match. I was watching that match and he dropped the stupid catch. To err is human, to forgive is divine. So I'll forgive you for this small mistake. I have done a lot of mistakes in my life. 1 by U plus 1 by V is equal to what? 1 by F. The actual formula should look like this, 2 by R, where R stands for the radius of curvature, since R by 2 is 1 by, oops, what is happening here? Since R by 2 is 1 by F, I can write this formula in this fashion. 1 by U plus 1 by V is 1 by F, the legendary mirror formula. There is a derivation for this mirror formula as well, which we are not going to discuss in this class. That is a part of your board exams and that would be done in the board wala class. Do we understand this? Yes or no? Now remember, all these formulae, whatever we have written, must be used with what? They must be used with proper sign convention. If you do not use it with sign convention, these formulas are invalid. These formulas are invalid if we don't use it with sign conventions. Now, since sign convention is there, focal length will also have the sign convention. Now we have two types of mirrors, so therefore we might have two types of focal length according to sign convention. Now let me take you back to the past. I have a time machine and I can go back in past. My son says Doraemon has a time machine. I think he has. He also has a time door which can open anywhere. So we have become Doraemons and we have gone into the time machine. Now tell me, which focal length is positive and which focal length is negative? It's right there on your screens. You can also see their focuses. You can see their focal lengths and tell me which focal length is. This is the focal length of this lens, this mirror, sorry. And this gentleman is the focal length of this mirror. So you can easily now tell me according to sign convention which is what. Yes, I wait for your answers.
B is positive, A is negative.
What is B, my dear friend? Arey, which mirror?
Focal length of convex mirror is positive.
Focal length of convex mirror is positive. That is absolutely correct, my bacha. For a convex mirror, remember, not lens. For a convex mirror, focal length is positive. You can easily see it. For a concave mirror, the focal length becomes negative. Is it clear to everyone in the class what we are discussing? And it is very evident from the discussion that we have that for a concave mirror, and you will write it as an important point, you should never miss it. For a concave mirror, the focal length is negative, and for a convex mirror, the focal length should turn out to be positive. Yes or no? No or yes? Do you understand this? Shall I move forward in life? Because life has to move forward. Time only goes in one direction. Since we are Doraemons, we can actually go back in time, but that is quite difficult to do in actual real life because it will require a large amount of energy. Probably we'll get into some paradoxes as well. Do we understand this? Up till now, so far so good. The smaller class which has 5 students. Are we done? Because they do not have a mic as well. So okay. Okay, now I will again go around, and just to save some precious time, I will show you this, and I hope that you understand what I mean to say. Nothing very complex, because I don't like complicated things. My life is although very complicated, so I try to make it as simple as possible. And here is a small table that I am showing it to you. Oops, wrong color. I'm very peculiar about colors. I hardly know colors. 4 or 5 colors. I'm okay. For a concave mirror. For a concave mirror, what are the things you must remember? For a concave mirror, focal length is negative. Do we understand this? Yes or no? For a convex mirror, focal length is positive. Do we understand this? Yes or no? Okay. Now remember, if the object is real object. If the object is real, it will be on the left hand side, and therefore, my dear friends, your u will always be negative. Are you getting my point? If the object is real, your u will be always negative. As you can see, it is always negative. Yes or no? Because it is on the real side, my object will be here, my mirror will be here, rays will go from the object, and again your distance will be in the opposite direction. Yes or no? No or yes? So for a real object, that is what you must note down as point number 1. For a real object, u is always going to be negative. Do we understand this? Number 2 point, which I'm again going to highlight, height of an object.
Hello.
Yes, beta. Oh, yes, sir. Sorry. For a real object, and the normally object is erect. So for a real erect object, or for a erect object, if the object is erect, the height of the object will be positive. Do we understand this? If the object is kept like this, the height will be positive. Yes or no? Height of the object would be positive. You may not write what is there in the entire sheet. I'm just highlighting the important points that you got to write. Yes or no? Point number 3, real image. If your image is coming as real, it will come on the real side. It will come on the reflected side. It will come on the shining side. So in that case, your V will be negative. Do we understand this? A real image is always inverted. A real image is always inverted. So height of the real image height of the real image I would be negative. Is it so complicated to understand? Yes or no? Is it complicated? If the object is real, you will be negative. If the object is erect, height will be positive. If the image is real, v will be negative and the height of the real image will be negative. Do we understand this? These are the 4 points that you have to write. You may not have to write the entire thing. There is no point of writing the entire thing. These 4 points is what I am concerned about. And I hope that you have understood these 4 points, which are there in a very small little box that I have created. Do we understand these 4 points? And remember, 99% of the questions that you are going to get, they will be on real objects. 99% of the question that you are going to get will be on real objects. Only 1% of the question will be on virtual objects. Now, someone asked me, sir, give me an example of a virtual object. Now, at that point in time, it was difficult for me to make you understand how will you create a virtual object. But in the coming days, when we go somewhat further in our discussion, we'll understand how virtual objects are created. How virtual objects are created, and I'll give you a homework on that. Homework. If you can do it. I have not told you how virtual objects are created, but that is your task, that is your homework that I'm going to give you. When will you get a virtual object? If I hold this is a real object. If I put it in front of a mirror, it will be a real object. It might create a virtual image, it might create a real image. But in which case are we going to get a virtual object? That was the question. Question based on virtual object came in this year JEE Advanced. It might be difficult from the level of NEET, but they can easily give you because there was nothing much complicated in that question. So we will try to see in the next class when how we are going to apply these things that we have understood. 99% of the questions will be based on these things that we have discussed. And I've given you a task, I've given you a homework to find out how and in what cases will we get virtual objects. And if I might give you one more thing as homework, I guess you must be knowing it from your previous experiences. If you can do this, if you can do this table, which I'm going to show, this table must be done by you in your smaller standard. I guess in your 10th standard you would have done this ray diagram. Yes or no? You have done ray diagram in 10th standard, and in those ray diagrams you would have seen what happens when you place object at different places. Yes or no? So you place the object at different places and you find out where the image is formed. Have you done this in your 10th standard? Yes or no? For concave mirrors, we have 6 points. Number 1 point is when you place it at infinity. Number 2 point is between infinity and center of curvature. Number 3 point is at the center of curvature. Number 4 point is between F and center of curvature. Number 5 point is at the focus. And number 6 point is between the focus and the mirror. Do you know where the images are formed and what type of images are there? Because question based on this is going to come in your exam, NEET exam, more likely. Do you know where the images are formed and what type of images are there? Yes or no? You know this? No? This is yes, this is no. How many yes, how many no's? We don't know. Okay, one class knows, the other class does not know. So again, this is a task for the other class to find out where the image is formed and what is the nature of the image. That is what you will do before coming to the next class so that we can move further ahead in our discussion. For convex mirrors, there are only two positions possible. One position is infinity, number one, and the second position is anywhere between infinity and the pole of the mirror. So convex mirrors is very simple, only two positions. Concave mirror, you have six different positions, and I would request you to do all these six positions and find out what type of image is formed and where, because question based on this is going to come. We will discuss this in the next class. I will discuss each and every position. I may not be drawing the ray diagram because it will take more time. I will be telling you to draw the ray diagram accordingly, but we will discuss where the image is formed. So I'll see you in the next class.
Sir,
Take
am I
care.
audible?
Yes, beta. Take care and have a
ఉపాధ్యాయుల దినోత్సవం సార్